Hi everyone! In this video we will solve exponential equations using natural logs. Solve, round the answer to the nearest tenth. Here we have 5 times e to the negative 10x equals 16. And we want to solve for the variable x, but it's in the exponent. So let's try and isolate it as much as we can. In this case, we can divide both sides by 5, and then we have e raised to the negative 10x equals 16 fifths. That exponent is still up there, but it's a little less crowded. Now we can go ahead and do either one of two things. We can rewrite this exponential equation as a logarithm using the definition of logarithm, or we can take the natural log of both sides using the one-to-one property. Both will work perfectly fine, and you can use whichever one makes most sense to you. I will show it both ways. We'll do one on one side and one on the other. The first one, we'll just go ahead and rewrite the natural log of our expression. So if I have a to the b equals c, this is rewritten as log base a of c equals b. And so we can just rewrite this as log, and we are in base e, and e is the natural number, so it gives us the log base e, or the natural log, ln, of the number, which is on the opposite side of the equal sign. This is where the c is. So in this case, it's 16 fifths. And this equals the exponent, which we have as negative 10x. Then to continue solving for x, we divide both sides by negative 10, and we get x equals the ln of 16 fifths, all divided by negative 10. And to type that into your calculator, you'll want to put parentheses around the 16 fifths, so that's all inside of the logarithm, and then divide by negative 10 and press enter on your calculator. Now let's go ahead and try it using the one-to-one property. The one-to-one property says that if I have something like m equals n, then I can take the log of both sides, just like we've done any other property of adding something to both sides, subtracting, or multiplying. As long as we do it to both sides, it keeps the equal sign balanced. And the logarithm does the same thing. We can take the log of a new base, b, or of any base we want, equals of m, equals log of the same base, b, that we picked in the first one, of n. And so in this case, because we are working with the e here, the natural number, we will pick the base b to be e, meaning that we'll take the natural log of both sides of this. So we have the natural log of e negative 10x equals the natural log of 16 fifths. And then we will employ one of our rules that we've learned, which is the product rule, and we'll roll this negative 10x down in front, negative 10 times x times the ln of e. So just to simplify this a little bit, we'll write it out, negative 10 times x times the ln of e equals the ln of 16 fifths. And then we will use our inverse property, which is if I have the same base down here as the number that these match, and because this is the natural log, the base is e, then the answer to evaluate that is the exponent. Since there isn't an exponent, there's an implied 1 here, so this is a 1. So we have negative 10 times x times 1, and negative 10x times 1 is just negative 10x. So we get negative 10x equals the ln of 16 fifths, and then we will divide both sides by negative 10 to solve for x. And you'll see we have the exact same thing no matter which way we solve the equation. So we can rewrite on the left side you've seen, and on the right side we can take the logarithm of both sides. This is the one-to-one property. Now to type this into your calculator, we will go to the bottom left and move up 3 buttons on a TI-84, and you'll see ln, this is the natural log. Press that button and it will open a parenthesis, and we will type in 16 divide by 5, and then close the parenthesis, making sure that we get both the 16 and the 5 into the logarithm. then divide by negative 10. Pressing enter gives us negative 0.11635. We'll stop there because we were asked to round this to the nearest 10th place value. So we look at the 10th place value. The number to the right is less than 5, so this all rounds down to 0, making this negative 0.1. We have now solved our exponential equation, and we're all done.